I'm going to present my bachelor's thesis today, and what I've done is that I've programmed a program to extract benchmarks from GitHub in Rust. So I wanted to begin with saying, explaining a bit about what benchmarks are. So in our case, or in my case, it's programs that are used to test other programs. So we have an example here. So here we have a small hello world program, and it's being put into the Rust C compiler, and then we get an output, which is hello world, which is what we expect. And what happens here is that this small program here tests the Rust C compiler to see that we get a result that we expect. And in this case, this is a benchmark to test the Rust C compiler. So then let's make a scenario here that I want to test the Rust C compiler, and I create a collection of benchmarks, also known as a suite of benchmarks. So I have 3 small toy programs here, and these are just some programs that came to mind. So it's to calculate and greet and multiply, and then when I compile it using the Rust C compiler, I get 3 compiling executables that have the results that I expected. So here we see that the Rust C compiler works on the benchmarks that I created. So I tested the Rust C compiler on 3 toy programs that I came up with on the fly. But then how can I ensure that the Rust C compiler is gonna behave as I expect for a program that I just took from the internet on GitHub? So this is a program that was actually taken from the internet. It's from a repository called Curse Rust Talk, and since the Rust C compiler wasn't tested on similar programs to this, I can't make sure that it will result in something that I expect. So this scenario reminds me of the good weather bias, actually, and it's when autonomous car manufacturers train their autonomous cars on data where the weather is perfect. And the problem there is that then the car doesn't know how to handle when the weather isn't perfect. So if there's a storm or if there's a road work up ahead, and this has actually caused deaths before, because the autonomous cars wasn't trained on proper data or representative data, so data that actually represents what the real world looks like. Okay, so let's get back to my work. I chose GitHub as the source to extract my benchmarks because it has a lot of activity, it has a lot of active users, and also it's the norm today for putting your code on the internet. You can also see some statistics on this slide about the activity there. Okay, so first thought of extracting benchmarks. Should we take a repository from GitHub? The problem with using code repositories as benchmarks is that they're very big. Sometimes they could, like in this example, it's a repository that's 240 megabytes. And since you want to test your program on something representative of the real world, you can't just use one of them. So you want to have a collection of benchmarks. So a benchmark suite. So using repositories is way too big. But then the next computational unit that's smaller, so the next program, like when you have an input into the black box and then you get an output, would be a function. But and when you take a function as well, it becomes much smaller, like in the example. But the problem when you copy and paste a function is that out of context functions, they stop working because they often reference other parts of the program. Like in the example, we have a bunch of undefined types and methods that the compiler just doesn't understand. And my approach fixes this problem. So my contribution in my thesis is that I take a function that I want to extract into a benchmark, and then I resolve all of the types and methods and functions that reference external crates or external dependencies. So for example, in this example we have regex, and here what would be needed to be done is to import the external library. Okay, so let's do an example of how my program extracts a function. So we have this function here that we want to extract, and it has bar type, which is an internal type. It has an external dependency, regex, and then it has a method from that implements the bar type type. And then it takes the original function and it also extracts the bar type struct, and then the implementation of bar type with the method new. And also to resolve the call to regex, it writes use regex, and this is like an import statement in Python, but this is just for Rust syntax. So we have bar type, and we have new, and then regex. So now that works. But now that we imported the new method, we run into another problem, and it's that the new method actually itself makes a call to an external library, which is called rand, to generate random numbers. And here what my program does is that for each method or function that it extracts, or any source code that it extracts, it will recursively check if it has any more types or method or functions that it needs to extract. So now that it sends that it calls an external dependency, it adds another use statement to import the random library. So my program is actually much more complex than that. So if you will want to know the full picture, you would have to read my report. But I can say something interesting here is that we don't actually need to extract all of the types and methods. Like for example, there are some that are standard, like for example just string, like the built-in, like string or vector or arrays, and those we can actually ignore. So okay, let's talk about evaluation. So how do I know that my program works and that it behaves as expected? So I did two types of evaluations. I did first on a synthetic project for sanity checking, and also just to know what kind of language features that I want to implement support for. And after that, I did a larger scale empirical evaluation, meaning that I actually extracted some code from the internet and tried my program on this code. So to generate the synthetic project, I asked an AI to generate the whole project, and the prompt looked something like this: generate me a very complex project with a bunch of different language features so that I can test my program on it and extract benchmarks from there. And the functions in this synthetic project look a bit like this. The first ones are very simple, and then near the end we have much bigger functions that call references a bunch of different files in the repositories and has external dependencies and such. And this is the structure of the synthetic project. In the end, I landed on 1,102 lines of code with 76 target functions, meaning 76 functions that I was gonna try and extract using my program. And by the end, I could extract 13 of those functions successfully. which is 17.10%. And here are some examples of problems that I ran into, like for example here, trait bounds. It means that the print twice function needs to take in a type that implements a method called display, which I don't support yet. And then we also had some, I also got some double imports here, which would need to be fixed. And the problem here is that it didn't import the type because it looked for ampersand point instead of point. So these are problems that I did not have time to fix yet, but I can fix them if I implement support for example trait bounds. Okay, let's talk about empirical evaluation. So I downloaded 147 repositories that contained Rust, and this was from a dataset that had been mined using Cyros, which is a tool to mine GitHub. And then from these 147 repositories, I randomly sampled 385 functions that I ran my program on. And in the end, I had 7 compiling benchmarks, 253 that were not compiling but successfully extracted, and then 114 of them couldn't even be extracted. These are some of the examples of the 7 compiling benchmarks. We have a very simple one with just a standalone function, and then here's a more complex benchmark that it managed to extract, which references the a type inside of the lib.rs file. And then in the 253 non-compiling benchmarks, here are some issues that I ran into. For example, I extracted the function within the implementations, which was deeply nested within 4 folders: token, PSP22 extension vault, and this was just a structure that I didn't expect running into. But to fix this, I would just need to add module files in between each folder, which is one example solution to that. And then I also ran into a problem where people had written code inside of the module files in here. And my program extracted the code from the module file, but then my program also wants to create a module file, so it writes over the created module file, which removes all the code that was there, and then it tries to import the original module file by just writing pub mod, but that's completely illegal. And then there was also some references to nightly, to methods that are only allowed in the nightly Rust compiler, which is an experimental compiler. And my benchmarks use version 1.91.1 of Rust, so it didn't understand it. And then all the unsuccessful extractions were because my program couldn't find a function at the line that was given. But this has actually been fixed since, because there was a hard-coded bit in it, which I removed, but that's fixed since. And now I just wanted to say that I'm done with the presentation and you can ask questions now.